Well, I think that's where I may have messed up.
So let's look at number 7 on worksheet 6. And yes, we would square both sides. And we would have to FOIL the right-hand side. That's true. So the left-hand side's easy. 1 minus 2x. The right-hand side, when foiling, sometimes I write it out. Other times I'm confident enough to do it without it. But weird stuff like this, I would probably write it out. Square root x times square root of x is x. The O and the I of FOIL are both square root of x, so we end up with 2 square root of x plus 1. And then there's still 1 minus 2x on the other side. So our initial job is to get this square root of x by itself. So subtract 1, subtract the x. So negative 3x equals 2 square root of x. Let's see, divide by 2, we get negative 3 halves x equals square root of x. Am I going too fast? Are we okay?
Yes, sir. I realize where I messed up.
Okay. Let me go ahead and finish it out. Square both sides. And this is the second time we squared both sides, so we really need to check our answers to see if this is working or not. 9/4 x squared equals x. So I'm going to move the x over. Although one person I asked today, they multiplied through by 4 to get rid of the fraction. That's fine too. Factor out an x. So yes, we have 2 solutions. X equals 0. That's the easy one. And then the other one, I'm a little short on space, but I'd add 1, multiply by 4/9. So 0 and 4/9. So almost out of room, but checking 0 is easy. Square root of 1 equals square root of, or no, equals 1. So yes, 0 is fine. 4/9. Let's check that. Square root of 1 minus 8/9 equals square root of 4/9 plus 1. 1 minus 8/9 is 1/9. Square root of 1/9 is 1/3. Square root of 4/9 is 2/3. And again, I don't have to be a fraction expert. 2/3 plus 1 is not 1/3. Whatever it is not 1/3. So that means 4/9 did not work. Only x equals 0 worked. Square both sides, and when you square both sides, you'll have to check your answers at the end. And this is a good one because one worked and one did not. Julie?
Will there be a case where both don't work?
There could be a case where both don't work. Yeah. Yeah, there's no guarantee that if you get 2 answers that one's yes and one's no, or yeah, it could be anything. All right, how about some questions from worksheet 7? Resume.
Means with speed and efficiency.
There we go.
Wow. You should be an English teacher.
Fool. All right, so what I'm going to do, this is how I'm going to shepherd us through the review process. I'm kind of keeping an eye on the units that we did or the topics that we did. So we'll kind of hit 1 from each, maybe 2 if there's multiple things going on. So I've got this kind of off to the side guiding my selection process here. So first thing was simplify rational expressions. That's problems 1 through 7, which means if you could do 7, you could do any of them. 7 is a division problem, but division problems turn into multiplication problems. But before I can even do that, I've got to take care of this denominator, right? Because I can't keep it, change it, flip it until I have one fraction over another fraction.
Whoops.
5-second rule. You're good. You're good. So this first denominator, or the second denominator needs a 5. The first denominator needs an x plus 3. So that gets us 2x plus 6 minus 35. Again, I'm literally covering up the numerator to emphasize I need to clean up the denominator first, then we'll do keep it, change it, flip it. So 2x minus 29 over 5 times x plus 3. So that's my denominator cleaned up into one fraction. And so that reviews numbers 1 and 2 and 3 basically. Now we still have the numerator to worry about. Now we can keep it, change it, flip it. 6 over x plus 3 times 5 times x plus 3 over 2x minus 29. So the x plus 3's will cancel. 6 times 5 is 30 over 2x minus 29. So that's a good one because that covered everything from that unit. Add, subtract, multiply, divide. We just about did it all. The next day was solving rational inequalities. So that's like 8, 9, 10, 11. So we need to do 10 and 11. Probably 11, because if we can knock out 11, you can do any of them. You tell me, what makes 11 different than 10? Just kind of one thing in particular. There's powers, so there's a double root and a triple root. It is already factored, so that's nice. Let me back up for a second. The process is zeros on a number line, test the intervals. That's how we'll do inequalities. Find the zeros, top and bottom, put them on the number line, open circle versus closed circle, intervals, usually alternating. So, already factored, that's nice. So the top zeros are 0 and -1. The bottom zeros are 3 and 7. I don't have to have them like equally spaced or spaced, to scale. I do have to have them in order though. So -1, 0, 3, and 7. Again, not the scale, but I don't really care about scale. My top zeros, are those going to be open circles or closed circles? Closed. Why closed? Right, the equal sign means I can go closed for the top. The bottom has to always be open because the equal sign doesn't matter. I'm not allowed to divide by 0. So x can't be 3, x can't be 7 because then I'd be dividing by 0. And as you pointed out, -1's a double root, so I better be very careful about the alternating rule there. 3's a triple root, but a triple root is still going to cross on the graph, so it's going to change signs. So the alternating root still applies at 3. So I don't really even care that it's a triple root. It's not going to matter. So 5 intervals, but I know the shortcut. I don't really want to test 5 intervals. I want to test 1 and alternate off of that. So let's test, both one interval and the number 1. And that will tell me what's going on in this interval. So already factored. I don't really care about the number. I care way more about the sign. So if I plug in 1, I get negative. 1 plus 1 is 2. 2 squared is positive. And in the bottom, 1 minus 3 is negative. Negative cubed is negative. 1 minus 7 is negative. And I want to know if all of that's greater than or equal to 0. So that's a lot of minus signs. More specifically, it's 3 minus signs, or an odd number of minus signs. So negative number greater than 0. Yes or no? No. So that region is a no. I can definitely alternate to the right because there's no double roots to worry about. So 3 to 7 is a yes. 7 to infinity is a no. Moving to the left, when I cross over 0, that's not a double root, so I can alternate across there. But when I cross negative 1, it's going to be the same thing, so that one's also a yes. You don't alternate across double root. It won't always be filled, because that could have come from the denominator. And it won't always be yes, yes. It could have been no, no.
If it's on the top, then it will be?
If it's on the top, it would be a top and equal to, it would be a closed circle.
You know what I'm saying? Like, if the double root's on the top, will it always be filled? Or, like, how do you know that?
Like, when you say filled, you mean the circle filled or both both of those intervals?
The shading in the space. Yeah.
If I had switched this to less than, it would switch all of those and it would be no and no.
Mm-hmm.
So it's not always yes, yes.
But how do you know that? Like,
Because I use the other ones. If you're not sure, you could plug in negative 3 and see. But I can still use the alternating rule. I just don't alternate across the double root. And again, it's like, well, we're being very trustworthy here that my alternating works. If you're not sure, check negative 3. Shouldn't take too long. Negative 3 is a positive. Negative 3 plus 1 squared would be a positive. In the bottom, negative 6 cubed would be a negative. Negative 3 minus 7 would be a negative. So positive greater than 0, yes, it works. So I would recommend you test more than one interval. I mean, if you're really pushed for time, then alternate and hope you got it right. But if you got a little bit of time left, check an interval a couple spots away and make sure everything sort of works out. All right, inequality notation. So x needs to be less than or equal to 0, or between 3 and 7, but not including 3 and 7. And I said the right thing and wrote the wrong thing. Less than or equal to 0. Find the zeros, put them on the number line, test at least one interval, and use the alternating rule, but just slow it way down and be super careful with the double root. All right, the next day was partial fractions, so that's 12 and 13. Do we need to see one of those? Would someone like to see one of those? Okay. Those are basically the same type problem. I guess 13's harder because you've got to do your own factoring, but that's not a hard factoring job. So let's do 13. 21 minus x over x minus 5 and x plus 3. So again, this is like unadding. Somebody added two fractions to get that. The denominators would have to have been x minus 5 and x plus 3. Don't know what the numerators were, so we'll just go A and B. That's what we're trying to find. Right? Don't like all the denominators, so we will multiply by the original denominator because that will kill off all of the denominators. So left hand side's easy, it cancels everything. right hand side on the first term, the x minus 5's cancel. X minus 5 cancel. So that leaves a times x plus 3. On the b term, the x plus 3's cancel, and that leaves x minus 5. What do we want to do next?
Plug in things for x.
Yes. What would be a good thing to plug in for x? 5 will work, because we're plugging in things that are going to wipe these out and make our life a little easier. So if we let x equal 5, 21 minus 5 is 16. 5 plus 3 is 8. 5 minus 5 is 0. That's why we picked 5, to make that term go away. So a equals 2. Right, let's let x be the other thing that would make some things go away, negative 3. So 21 minus negative 3 is 24. Negative 3 plus 3 is 0. Negative 3 minus 5 is negative 8. And then b would be negative 3. And I'm kind of done with the problem, but I'm not really done until I, Jeopardy style, give your answer in the form of a question, correctly formatted. So a over x minus 5, that would be 2 over x minus 5. Plus b, which is negative 3, over x plus 3. And again, almost nobody ever checks that, but you could if you had plenty of time and you wanted to make sure you were going to make 100. Get the common denominator, add everything back together, and you should get 21 minus x. That's the problem. That's a long process with a whole bunch of steps, none of which are really that difficult. It's just, can you remember all the pieces to do and not make any mistakes along the way? All right, the next thing was graphing rational functions, and there's a whole lot that goes into graphing rational functions. So I think let's skip ahead to number 32, because that's the graph. That covers almost everything, and then we'll go back and hit a few of fill in the blanks on things. So what should we do first for number 32? Factor it. Trying to get it to focus better. Maybe that's better. Yeah. So I'll factor out the negative. X squared minus 2x minus 15. And then factor what's on the inside. X minus 5 and x plus 3. Back to the bottom. X plus 3, x minus 3. Now I'm ready to answer the questions. So I got to get everything factored nicely. I don't like how this is asked because it's missing a question. Do you know what question it's missing? Domain. So let's go ahead and just add that question, because that's how I'm used to working these problems. So the domain is what x can't be. Can't divide by 0, so x can't be 3 or negative 3. And we can abbreviate plus or minus 3. Are there any holes?
Oh yeah.
How did you know?
There's an x plus 3 on the bottom and an x plus 3 on the top.
Yep, factors that cancel make a hole. What about the y coordinate of the hole? I'll get into what's left. So negative 8 over negative 6. All the negatives. Negative 4/3.